Okay, so we're going to, for example 4, we have to use theorem 4.2 here. What theorem 4.2 here says is if we if we bisect the vertex angle of the isosceles triangle, then it's going to be a perpendicular bisector to the base of the triangle. So let me just draw another one as an example up here. Okay, if we have an isosceles triangle here, the base angles are the two angles that are going to be congruent at the bottom here, right? So these would be the congruent angles by our isosceles triangle theorem. Okay, those are the base angles. So base angles, right? This is a base angle. This is a base angle. And then your vertex angle is the one that's basically between the two sides that are congruent. Okay, so your vertex angle, your base angles are the ones that are congruent, and then the other one is called the vertex angle. So what this is saying is if we bisect that vertex angle, right, if we split it into two equal angles, so if we make this angle equal to this one, we bisect the big one, we split it in half, then this bisector is also going to be a bisector to the base. So that also means this piece and this piece are going to be congruent. Okay, and it's perpendicular to that base as well. So you would also have right angles here. So if we bisect the vertex angle, it's also going to be a perpendicular bisector for the base. So perpendicular means you have right angles, and then it's a bisector of the base. So that means these two pieces are the same. Right, so here's your isosceles triangle, right, the big one, ABC. So these are your angles that are congruent. Those are your base angles. And so when we bisect this vertex angle, which is B, right, 60 and 60, so we're splitting that in half, then we have a perpendicular bisector across the base, right? So 90 degrees on that side, 90 on this side, and then again, AD would be congruent to DC here, so 4 and 4. Okay, and they show you that here as well. Okay, so you bisect it. You bisect the vertex angle, you're going to have a perpendicular, the line's going to be perpendicular to the base, and then you're also splitting the base into two equal pieces. So let's look at our example. Let me start erasing this. It doesn't go super slow. Okay. All right, if we look at our example here, we can read this. We don't really need to necessarily, but we should probably. A prefabricated house is delivered to a foundation in two symmetric halves that are assembled on site. Along the planned route to the site, the truck must pass under a bridge that has a clearance height of 17 feet. Should the trucker plan a different route for delivering the house? Explain. So we need to basically find the height of our house and see if it'll fit under a 17-foot bridge. Okay. So we have the height of kind of the base or house portion of the house, and then we need to find the height of the attic portion up here. So we need to find the height of this triangle. So we know the length across the whole bottom of the triangle here is 28. Let's draw it out here so we have it bigger. Okay, so this is B up here, and then this is C. Okay, they're telling us that this piece in the middle here it's being bisected because it's cutting angle B in half into two equal pieces. We know the base across the bottom is 28, so we know each of these pieces is going to be 14. So 14 and 14 here. Right, this is using theorem 4.2 that we just had, right? When we bisect that vertex angle, then it's going to be a perpendicular bisector of the base of the bottom here. Okay, and then we know the hypotenuse of a right triangle is 16. So if we should remember from previous math classes, If we have a right triangle and we're looking for one of the sides, we got to use the Pythagorean theorem. So I'll do it in red up here. So a squared plus b squared equals c squared. Okay, so quick review on that. A and B are the legs, and then C is your hypotenuse. So the hypotenuse is across from the right angle. So that's your C. All right, so let's put that in parentheses. Okay, and then the two sides adjacent, right? So across from the right angle is your hypotenuse. Adjacent to your right angle would be your legs. So we can call those A and B. Okay, those are going to be the legs. Okay, the legs are adjacent to the right angle. Adjacent means next to, right? So if you're sitting next to someone, you're sitting adjacent to them. If you're sitting across from them, you're sitting opposite of them. All right, so our A and our B are x and 14, so we'll do x squared plus 14 squared. Okay, equals 16 squared. Okay, so that's going to be x squared, 14 squared. It's going to be what, 196? And then 16 squared is 256. Okay, let me just double check that real quick. I mean, it is, but I'm just paranoid, 196 and then 256, just so I don't have to redo the whole thing. So we subtract 196 from both sides, and we're going to get x squared. Okay, it's going to equal, that's 56 plus 4, so that's going to be 60. Okay, that didn't work out. Okay, and then you got to take the square root of both sides to get rid of the square. So we take the square root of both sides, so the square root of 60. It's going to be more than 7 and less than 8. So it'll probably be like 7.8 here. Square root of 60 is 7.7 feet. Right, so it would be 7.7 feet. Okay, so our height is 7.7 feet. So if we look at the height of the whole structure, this piece right here would be 10. And then this piece would be 7.7. So our total height here would be 17.7 feet. So it's going to be too tall. It's not going to be able to get under the bridge. Okay, so it's not going to be able to fit under the bridge there. So if we look at our solution here, right, they use the Pythagorean theorem. Square root of 60 is about 7.7. So it's not going to fit under the bridge. Okay, if we just look real quick at your try it then. Okay, they're looking for the measure of angle RSQ. Okay, so we have an isosceles triangle, so this one over here is also going to be 31. Okay. Since this angle is being bisected, the vertex angle of our isosceles triangle is being bisected, that means SQ here is going to be a perpendicular bisector. So since it's perpendicular, you have right angles there. And so now you have 90 degrees and 31. You should be able to use the triangle sum theorem to find the third angle of the triangle. Okay. And then you got to find PR. So if QR is 4, we also know PQ is going to be 4. And then you can find the whole thing. 4 plus 4 should be 8.